Today's lesson, we are going to take a look at comparing and contrasting data distributions with the idea of determining where the variability is the most and where the variability is the least. So by looking at a graph, can we see how variable the data is? So we're going to start off by just reflecting back on our mean and median calculations. So for each one of these sets of data, we're going to go ahead and get the mean and the median. So we're going to get the mean for the first one. We'll notice that if we add them together, 27 plus 30 plus 33, and then divide by how many there are, we get, in this case, 90 divided by 3, which is 30. Since the numbers are already in order, the middle number is the median. So the median is also 30. In the second set, we can take a look and see, okay, if I add these together, 61 plus 71 plus 81 plus 91 plus 101, and divide by 5, I get a mean of 81. And if I look at the middle number, I also have a median of 81. So you can start to take a look at those two sets and see, okay, why is that true? Why are the mean and median the same? However, in the third set, if I add these together for the mean and divide by how many there are, in this case 5, that would be 400 divided by 5, which is 80. And the median, again, the middle number when they're ordered, in this case is 100. So the mean is less than the median. And then for set number 4, again, let's add them together. 5 plus 6 plus 7 plus 8 plus 25, which I believe is 51. And 51 divided by 5, because there are 5 numbers, is 10.2. And if I look at the median, that's going to be 7. So looking at the data sets, we're going to see, all right, in which data sets is the mean and the median equal to each other? Set or sets, where are they equal to each other? So if we look right here in set 1 and set 2, the mean and median are equal to each other. So set 1 and set 2. Why is that the case? Well, we know the median is the middle number in each set. But when we're calculating the mean, in these cases, the higher numbers kind of balance out equally with the lower numbers. When calculating the mean, the higher numbers balance out the lower numbers. So the mean is equal to the median in that case. So you can kind of see in the first set, we have 33, which is 3 bigger than the median, and 27, which is 3 smaller than the median. In the second set, we have 81. So we got 91, which is 10 above, 71, which is 10 below, 101, which is 20 above the median, 61, which is 20 below the median. So they balance out. All right, let's change colors. In which data sets is the mean greater than the median? Okay, so look at that one. So that would be set number 4, right? So set 4. Why is that the case? Well, hopefully you're noticing this number right here. The 25 is what we call an outlier. It stands apart from the group. That's what an outlier is. So it stands apart from the group. And in this case, the outlier is higher than the rest of the numbers. So the outlier of 25 skews, we're going to use that term skew. Remember, skew kind of means it pulls it or tails off to that side. So skews the mean higher? In which data sets is the mean less than the median? All right, let's switch colors again here. So we've got the one that's left that we haven't talked about, and that would be set 3. So why is the mean less than the median? Well, once again, we have an outlier, but this time the outlier is on the low side. It's a smaller number. That 0 stands apart from the rest of the group. So the outlier of 0 skews the mean lower. So an outlier skews the mean. If you have an outlier, it's either going to pull the mean up or pull the mean down. If there's multiple outliers, they might balance out, but if you have one, they're definitely going to pull in that particular direction. So for each data set in the table, circle either the mean or the median to indicate which one is a more appropriate measure of center. Explain your reasoning. All right, so in the first two sets, switch colors again. In the first two sets, the mean is equal to the median. All right, so if we're going to think about which one is a more appropriate measure, really they both can be used. So in the first one, they both can be used. In the second one, they both can be used, right? But when we have an outlier, the median is really a better indicator of kind of where the center of the data is here. If you look at the data here, hundreds are really where most of the data is. So it would make sense that the 100 is a little bit better indicator of kind of the middle of the data than the 80 is. And same thing in the last one. If there's an outlier, the median is going to be the better measure of center. All right, that's more of a indicator of where the middle is. All right, so in the first two sets, the mean equals the median, so either can be used. They are symmetric. So oftentimes with the symmetric, we will generally go with the mean. Really, either one of them can be used. However, in sets 3 and 4, outliers skew the mean. So the median is a better measure of center. And again, center is kind of used like a general idea of kind of where the middle of the data is. Right, not the exact center, but kind of where the middle of the data is. All right, so we're going to be looking at a Desmos activity, and we may have let off with that Desmos activity already, or we might break right now and pause our video and go to it. So if that's the case, we can do that right now. You can pause the video. Otherwise, follow your teacher direction. We'll come back to the rest of the notes here. So in the next one here, it says each box plot summarizes the number of miles driven each day for 30 days in each month. The box plots represent in order the months of August, September, October, November, and December. Number 1, the 5 box plots below have the same median. Explain why the median is more appropriate for describing the center of the data than the mean for these situations. All right, so if you notice the box plots, each one of them kind of has a tail. The first one kind of tails off to the left. It's got that longer tail. The second one kind of tails off to the right. Same thing with the third one, kind of tails off to the right. Fourth and fifth kind of tail off to the left. So they all have some level of skew. So each one of the box plots shows skew. Either skew higher or skew lower. So skew towards the higher end or lower end. In these cases, the median is better. Is a better measure of center. All right, so now let's actually see if we can get into that a little bit further and rank the box plots where number 1 has the greatest variability and number 5 has the least amount of variability. Let's switch colors again. All right, so greater variability, remember, is generally determined by the interquartile range, or the IQR, first, and that's the box, right? The length of the box. And then we can also consider just the regular entire range as well. So when we look at the interquartile range for each one of these, let's just take a look. So that interquartile range goes from 20 to 60, so that's an interquartile range. I'm talking about this distance right here of 40. The second one has an entire interquartile range, the length of the box, from 10 to 70, so that is a length of 60. Third one, that's a length of 50. And the fourth one, 30 to 70, that's a length of 40. And in the fifth one, that goes from 30 to 50, so that is a length of 20. Okay, so we definitely have some rankings here. And so we look at the one that has the greatest variability. It seems like this one right here is the most variability. It's got a big range and an interquartile range. Interquartile range is generally what we look at first. October seems to have the next most variability based on the interquartile range. And then November and August both have the same interquartile range. So notice these two have the same interquartile range. So maybe the tiebreaker might be to go to the entire range. So if we look at the entire range, this one goes from 10 up to 80. So the entire range right there is 70. And on the first one, the entire range is roughly 5 to maybe, I don't know, 62 maybe. So that entire range is a little bit less. So I would say that therefore the one with more variability would be the November, followed by August, and finally December would be last because it's got the least. So you might just make a note over here. So even though they have the same IQR, the November plot has a larger overall range. So we're going to rank that one as more variability first. All right, we're going to finish up here with a kind of a similar question with the dot plots down here in number 3, all right? So the 5 dot plots have the same mean. Explain why the mean is more appropriate for describing the center of the data set than the median. Okay, so kind of on the first page we said we could use the mean or median. So generally when distributions are symmetric and there's no clear outliers, the mean is probably the best one to use. All right, so we're going to swing towards that vote a little bit more. So each of these distributions below, although they look a little bit different, you'll notice that each one of them is pretty symmetric. And there's no real outliers in any of these that stand away from the rest of the group. So each of the distributions are symmetric with no clear outliers. So if there's no clear outliers, the mean is the better measure of center. Okay, so let's look at these and see, okay, so from greatest variability to the least variability, unfortunately we don't have something like an IQR here to be able to really tell. So let's just kind of see here. All right, so variability means a lot of spread. So think about the ones that have the least spread versus the most spread. This one's a little bit harder to figure out. Well, look at this one right here. Oops, let's go back here. This one here has quite a bit of spread, and then it's got like the ends of the spectrum. It's got like clumps on both ends. All right, so it's going from 6 all the way up to 14, so that's quite a bit of spread, but it's kind of like there's no clear direction on where the spread is going, so it's like all over the place. So this one right here is probably the one with the most spread, the most variability. Looking at the other ones that go from 6 to 14 are essentially everything except for the last one, I guess. But let's see, which ones are more variable? Notice that the first two here and here have some data that's kind of clumped together. So that indicates that kind of less variability would be there. If you find clumps of data in one spot, that's less variability. Whereas this one here, this uniform data right here, is going to be kind of spread out but uniformly and not clumped together. So that has a lot of variability. Things could go from 6 all the way up to 14. We just don't really know where most of the data is. It's kind of uniformly spread out. All right, then the ones on the top here, we got to figure out, okay, which one has more variability? Well, notice that the second one here, we have a lot of numbers kind of clumping in the middle. And when you have clumps of data, and if it's clumps of data in one spot, then that's less variability, less change, versus the one up here where it kind of clumps in the middle, but over a larger space, a larger range along the scale here. So we're going to rank that one third, because although it has a clump of data, it's a little bit more spread out. That leaves this next one here as probably the fourth most variable. It's getting more consistent and less variable, right? And then for sure the last one, there's essentially no variability. So this one's definitely the least variability because all of the numbers are at 10. There are multiple 10s and there's nothing anyplace else. So that one is a pretty easy one in terms of the least variability. So we kind of have to reason through that a little bit for each one of these. It's not quite as easy as when we look at a box and whisker plot. That's a nice thing about a box plot, is that the interquartile range does give us a better indicator of IQR. And so we have to use our reasoning skills a little bit here to identify